Hi, everyone. Welcome to the Data Hub. And my name is Jacqueline. I'm the ODX Community Manager and the organizer of these Data Hub sessions. So can I get a show of hands how many of you have been here before? Okay. And whose first time is this? Okay, well, welcome to all of you. So ODX, that's Canada's Open Data Exchange. It's a private-public partnership, and the goal is to promote the use of open data as a means of wealth creation and job creation in Canada. So as I said, I'm the community manager for ODX. Some of the services we offer include helping you or your company locate data that you might be looking for access to, but you're not sure where to find it or if it is available. So please feel free to reach out to me or anyone on the ODX team. We also offer funding for open data related initiatives. So if any of this sounds interesting to you, please feel free to reach out. So I had this slide up at the beginning, but we have some companies around the Data Hub that are that have open positions. So Shiny Docs, Kite, Skywatch, and Greenland. Position names are listed up there. But if you have any questions about that, please feel free to talk to me and I can get you in touch with the right person. So these Data Hub sessions happen at least once a month, usually twice a month. So just to give you an idea of what's coming up, we have a session about data residency and the EU GDPR coming up in February. We have a session about machine learning and money laundering. So if you want to stay in the loop about what's coming up, please feel free to visit our website. And also if you're subscribed to the newsletter, you'll find out through there as well. So I'd like to introduce you to today's speaker. It's Olha Buchel. She's here to speak about interactive visualizations and how they can help us make sense of smart cities. Welcome.
Thank you for your interest in smart cities and interactive visualizations. I specialize in interactive visualizations, visual analytics, and sense making. I have a PhD from University of Western Ontario, and I worked at several companies in London, Toronto, and now next week I'm starting a position in Boston at New England Institute of Complex System Analysis. And I'm very interested in combining visualization with the modern, the statistical analysis that are currently done by businesses or by researchers. So before we start talking about interactive visualization, I would like to ask you, how much do you know about visualization in general? You probably know the difference between interactive visualizations and static visualizations. Up until recently, static visualizations were like a staple for all data analysis. However, now with better technologies, with better visualization libraries, we are able to start introducing interactive visualizations. Visualizations that can have various interactions. They can change representations over time. They can filter out data from representations, and they can help people understand the data. But I also want to make a distinction between interactive visualization and visual analytics. Until probably 2005, researchers in the IEEE visualization community were mostly working on interactive visualizations that were made from facets. Facets is basically like when you group data in various ways and you don't do much statistical processing of data. But starting from 2005 to 2010, when the first papers on visual analytics were published, there was that's when the movement towards more advanced statistical analysis and combining statistical analysis with visualization started. And the idea is that on the one hand, we can visualize, we can represent data, but it would be much better if we could combine this with the statistical libraries and we could show how the data is changing over time. And this is particularly interesting in the context of geospatial analysis and network analysis, because these models change over time, and they have completely different representations over time. I also want to talk about the purpose of visualization. While before, when we had the static visualizations and representations, we mostly used visualization for presentation of results. What happens now when we are moving more towards interactive visualization and we're moving towards visual analytics, we are suggesting to use data analysis at the initial stage of data analysis for exploratory analysis, so that you can develop your hypothesis by looking at the data. You look at how data changes, how different parts are interacting with each other, and then you might come up with your own hypothesis of why this is happening or what has to be investigated. Visualization is highly interdisciplinary, and if you want to specialize in interactive visualization or in visualization, you really have to look at the techniques from various disciplines, and you have to look what people have been using and how they use it. Perhaps some techniques that were developed, for example, in the geography, can be applied to biology or vice versa. However, from my experience and working with business researchers and talking to various businesses, I find that oftentimes people say, oh, we know what a visualization is, because they assume they know about visualization from static visualizations. But introducing interactive visualization and visual analytics is something that requires some effort to understand and work more on how it will work in the new, how this interactive visualizations can be combined with the old tasks, with what people are used to do. While I'm talking about interactive visualizations, I'll talk also about smart cities, because this is one of the big topics now in cartography, in computer science. In order to design visualization systems that would help people solve problems with communities, solve problems with city management, with the management of businesses. And smart cities are defined in various ways. On the one hand, people see smart cities as complex, like sets of complex systems that are composed of complex systems, for example, that are related to public health or to public safety, to education. And the goal of the city is to see how all these systems interact, because if one system has a problem or collapses, you know, other systems might be affected. On the other hand, the other researchers suggesting that a city is a complex network. It's a network of streets, a network of businesses, and we could apply here statistical analysis that are used for network analysis to analysis of cities. Also, another definition of smart cities which I liked was proposed by Rob Kitchen, that smart cities are cities that on the one hand are increasingly composed and monitored by pervasive and ubiquitous computing, and on the other hand, whose economy and governance is being driven by innovation, creativity, and entrepreneurship enacted by smart people. What I would add here is that we also probably need like smart visualizations, smart techniques in order to gain more insights about smart cities, in order to gain better hypotheses about what can be done and how all these multiple systems within cities can be managed. What kinds of data people understand when they approach the design of smart cities? I think the idea of smart cities started from information communication technologies, like from Twitter, from Facebook, or from Flickr, because those systems offered live data. And just by using the data from the systems, many researchers were proposing that this can be used in various contexts, not only to read messages from Twitter or from Facebook, but it can be used by police. It can be used for health analytics. You can learn about the spread of diseases. You can learn about many other things using information communication technologies. However, visualizing communication technologies per se and using, for example, bar charts or something else without really asking some questions of what you want to visualize and how you want, what you want to get from this visualization. Is not exactly a smart city approach. You have to weave it with tasks and questions that people are asking. It has to be meaningful and useful. It can so. The data from communication technologies can be combined with national censuses, government records, geometric surveys, and business data sets. However, all these data sets, business data sets, censuses, they are all based on samples. They are not continuous. They are not showing a continuous picture. However, they are still useful, and they can shed light on communication technologies. They can explain better what is going on with the communication technologies, what you can get from communication technologies. Here's an example of smart city implementation in Rio de Janeiro. And the idea is here that in one room you have a set of various systems that allow you to have a control over various subsystems in the city. And you can see, for example, if there is a crime in the city, and you can see how police is reacting. And then at the same time you can watch that it's a fact that ambulance is coming, that how other systems are involved in this. So that's the idea. That's the idea behind this visual analytics approach. There are some private companies that are trying to build smart city systems and for various cities across the world. However, like knowing interactive visualizations and knowing the ideas that they can be done with the visual analytics, I would say it's not probably the best approach, because all cities will be the same. But cities are different, and they have their own peculiarities, and you might want to have something more customizable. And what follows in this presentation, I will show you a few visualization techniques which are working, and I use them in a few business projects, some of them have been already published in business journals. So the first project that I want to show you has been published in the Journal of International Business Studies. It's one of the top business journals in the world, and the data set that we used for this visualization was a data set of Japanese multinational enterprises. The data set had around 100,000 records. Each record had up to 1,000 descriptors, but basically it was about subsidiaries, how subsidiaries were entering China over a period from 1991 to 2014. By looking at the data, if you give for visualization designer, he would say, he or she would say, this is these are like snapshots from various years. So you basically can visualize 1991 through 2014, and you can show how these locations are changing. However, there are different approaches that you can apply to visualization. And what we did with this data set, we decreased it to 10,000 records. And why we did this, we constructed a mini ontology about each corporation. And each corporation is represented as a set of subsidiaries. Subsidiary 1 started, for example, in Shanghai. The subsidiary 2 started in Beijing in 5 or 6 years. Subsidiary 3 started in let's say here, Shenzhen in 2005. So we collected, split the data set into these mini histories of each corporation. And what we used after that, the visualization that we've done and the analysis that we've done, turned out to be very interesting, because this is a very famous data set in international business, and there were more than 100 papers published using traditional statistical analysis, like various regression analysis. But what we've done, we basically were able to show something different with the visualization. So first we started with exploratory analysis, where these corporations are moving. So the red dots on this map show locations where maybe several corporations or one corporation started. And each corporation is represented as a line or an arrow. If a corporation started in this location and it moved to open the next subsidiary, then there is a line with an arrow. If a corporation started and did not move to the next subsidiary, then we had all these tiny arrows. The general view of the map was too dense, and it was difficult to make sense like what we see from all these movements, what conclusions we can make about the movements. That's where the interactive techniques come. And the first interactive technique that we used was filtering. And for example, let's take a look only at the subsidiaries, how they behaved from the first subsidiary to the next subsidiary when they moved from the first to the second one. And that's what you see in this image. That's the first. These are the first subsidiaries. On the second one, you can see the second and the third moves. From the second to the third subsidiary. When you look at these maps, you can see some, like when you compare these two views, you can basically see that these views are similar. They are basically moving around certain locations. And there are, you can sort of distinguish major locations in these movements. And what's important here is that, once you look at the image, you talk to people who know, for example, economics, who can interpret the data, and what they could say is that what they were able to identify with this, in these movements, they were able to see cores and peripheries. There are different ways to define cores and peripheries. So there is a definition in geography that, it's in economic geography, cores are agglomerations or sticky spaces. Peripheries are more remote and slippery spaces. In business, a core is an area with a high density of economic activity, and periphery is an area with a low density of economic activity. And in network theory, cores and dense cohesive structures are dense cohesive structures, and peripheries are loosely connected structures. Besides this, we used a few other techniques, and I used these are techniques that are coming. That have been developed on the one hand, some of them were developed in cartography, and some of them were developed by visualization community, like IEEE visualization community. On the first image, you can see magic lens. Basically, it's sort of a circle which can expand, where you can expand and narrow the radius of that circle, and its purpose is to filter out the data that you're not interested in. So, for example, you move the circle to Shanghai, and you can look what is going on around Shanghai. And you remove all the dots that were around Shanghai, and you can focus more on where did corporations go from Shanghai. Another technique is a convex hull approach. It's very interesting when you apply it with with a timeline. And what we were able to observe with the convex hull, okay, I have to give a definition of a convex hull. Convex hull basically puts a polygon around all dots which it finds on the map. So you can see that all the dots at a certain year were grouped around this area. But when you look how it changes over time, what we found that in later years, the polygon was smaller. It was shrinking. I don't know what was the explanation. Maybe it wasn't an incomplete data set. It's hard to say, but you can see this changes going on. Another technique which many people in business don't know, but cartographers are familiar with, it's standard deviation. It's a technique known as standard deviational ellipses. It's basically statistics on the map. You have 1, 2, 3 standard deviations on the map. So one standard deviation is within a small ellipse, 2 standard deviations within the larger ellipse, and the 3 within the largest ellipse. What this technique takes into account is allocation on the map. It's very useful. It's often used in health sciences. It's used by policemen to identify locations of certain events. Also, color coding, you can apply different kinds of color coding to the lines which connect the locations. While in the previous one, I had sort of a category, I applied categorical I applied color to categorical data, to categories of relationships. Here, I applied how fast corporations were moving. For example, if they were moving like after 1 or 2 years, or whether they were moving after like 5 or 7 years. And you can see additional patterns of what is going on with the corporations. While traditionally we know that all corporations and businesses, when you look on Google Maps, they are just shown as with a marker, and nothing else is going on with businesses. But here you can see something else. So once we were done with the exploratory analysis, and once we came up with the hypothesis that there is probably something going on with the cores and peripheries, we decided to find the proper representation for cores and peripheries. And it's interesting that in many map APIs now offer various techniques to represent heat maps, to represent density of certain objects on the map. And one of the most popular one is, like you can see on this second, third image. However, the problem is that they are very interesting. They are interactive. You can zoom in, you can zoom out, and they're all changing. But when you want to analyze, you need something else. You need something static, so that you can grab that layer, and you can cut out a certain area which is red, for example, or which is blue, and you want to do some further statistical analysis on this. And here's where the problem is, that what software can be used for this. And when you look at the tools that people are using for geospatial analysis, you can see that you can produce such layers. They don't look very nice, but you can see that you can produce these density layers with ArcGIS and Quantum GIS.
but like a layer is in a tool, but you want to use it somehow apply it to your own study. So what we did next, we used a D3 visualization library that allows to translate grid files, ASCII, with certain with additional coding, that allows to translate grid files to SVG imagery. When we translated this to SVG imagery, we overlaid this layer on a Mapbox API or Google Maps API map. And then when we've got additional meanings, because we have this layer, which is from our own data, and we applied it on top of Google Maps. And you can check what is going on. You can check what is going on with that map. You can zoom into the level of the city. You can verify whether it's exactly that location or not. Because in the high density locations, basically there are schools, Japanese schools, and there are like more businesses that provide the support for Japanese community. So the next step, what we do in visualization, that we allow people to cut out the layers. So, for example, you can draw a line around each layer, and you can cut out. You can select the dots which are in each layer, and you can add your own classification. You can name this area the way you want to name. For example, it was Shanghai core in 2014 or Shanghai core in 2010. And then once you apply this category, you can do further statistical analysis using regression or some other analysis. Relationships are not always like best viewed only on the map. There are many new techniques, especially the ones that are coming now with D3 library. D3 library stands for data-driven documents. And basically, you can plug in your Excel spreadsheet and you can visualize it, like showing, for example, a Sankey diagram or a core diagram or some other techniques which I will be showing on the next slides. But it is also possible to combine these representations, which are sort of static, which are available in these three libraries, with interactions. And you can create animations. What animations can show us? For example, these little dots or larger dots going from the cities where the first subsidiaries were located to the cities of the second subsidiaries and to the third subsidiaries. They go after a certain period of time. Sometimes they are like if it is a small dot, it means it stays there for a year or two, and then it began to expand. And you can see here, from the pattern here, you can see that from some locations you see only like small dots are coming out, and from a few locations, like from Shanghai and from some peripheries, the large dots are coming out. So basically, this can give you additional hypotheses about their behaviors across these locations. Visualizations can be of different degree of fidelity. Many people who use visualizations oftentimes things that, you know, like representing things the way they are, like exactly how they are. For example, showing lines between locations, connecting the lines. It will give you more information. That's true. It gives additional information. However, when you apply statistical techniques to analysis of relationships, you might find that, you know, you will get some emergent patterns. You will get some additional patterns from your data which you were not aware of. And as an example, I'll give you another visualization which I developed for another business paper. It's International Business Network Explorer. The data set contained relationships among countries. Basically, those were relationships among corporations and how they grouped together in order to form international joint ventures. But for this analysis, we didn't look at the scale of corporations. We looked at the scale of countries, and we looked at how countries connect with each other when they form international joint ventures, joint ventures. And by processing statistically all these relationships and the nodes, you can see that there are some nodes that are standing out. And for example, the US has the largest bubble, and it means that it often on the crossroads between all these relationships. Even though you don't see this from the data set, but it's between the centrality measure, which is often used in the analysis of networks, is very high. Also, each bubble encodes several attributes. So you can see in like a fraction of in and out relationships. The gray or khaki color shows out relationships, and other colors represent inner relationships. These other colors also represent groups. And that's an emergent pattern which is often used in communication analysis, and now is often used in economic analysis, that you basically, when you have a set of relationships, when you run through community detection algorithms, you can extract communities that exist. The data shows that that they exist in this data set. There are certain parameters how you have to evaluate whether it's there is a high probability of these communities or whether there is a low probability. Here, we basically have low probability in this visualization. But in communications, very often in communication technologies, very often you have real communities, and you might not know that these communities exist, but you can see communities that emerge on Twitter or on the Flickr. That are grouped based on how people relate to each other with through talking to each other. Besides this, you can see this tiny snapshots of all these networks, how they look over years. And before the visualization loads, I run this algorithm and I pre-compute in order for people to see what might happen over this 12 years and which years to select which ones are interesting, which ones are not. If they have a darker gray color behind, it means that it's probably they probably have a valid community. Besides this, you can select an area of interest on the map. And oftentimes, people don't know, why would I draw something on the map? But here, you have a question, for example, what can we say about these joint ventures, how they affect Africa? Because there was a lot of interest of investing in Africa, but do we see this through the data set? And when you select, when you select Africa, you have several options. You can look at the adjacency matrix that shows you how often these countries interact. Countries that are on the African continent and that are outside, and it brings it groups only countries which are related to Africa. And another one is a core diagram, which is very easy to use. It's very easy to see. Basically, you can see how countries are listed around this circle, and each country has its share of you can see its share of interactions, and it's more meaningful than a bar chart. Yeah, it's basically a combination of several bar charts. Besides this, you can combine this with spatial analysis, and you can look at the standard deviational ellipses, and you can look where is the center of incoming relationships and where is the center of outcoming relationships. And using multiple tools, using, for example, network analysis, then filtering out data from network analysis, then using geospatial techniques. It takes time to process this, but in interactive visualization, it's possible to combine all these types of analysis and do this in one system. Besides this, I'll show you an example of how you can analyze the communication. Although, all examples I'm giving here are at the level, are at the international level, but they can be used also at the level of the cities. What we've done for communication analysis in this project, we collected all comments and information about commenters from Flickr. And some Flickr members had their locations where they were located when they started their Flickr account. And then we analyzed all these comments, and we divided them into good and bad comments. Good comments contributed some local knowledge, some additional information about images that Library of Congress posted on the web. And bad comments were basically sentiments which do not add you much value. But in this project, we are basically showing that here geospatial aspect matters, because you can see that when you map location people who contributed good comments, and when you run geographically weighted regression analysis, basically analysis that show you averages on the map, you can see that the highest averages are where there is dark area in the US, and then in the red areas and pink areas, and then where you have gray areas, that's where the averages are the lowest. What does it tell you? It tells you that all comments were in English, and all communication was in English, but perhaps people needed a translation of some comments and some descriptions of images, and perhaps they would have contributed more. But it's also possible, what else we've done with this map, we also selected all these groups and divided that each group as a separate group, and checked in statistical analysis in the log linear model whether these groups are indeed separate. And what we found that people who are contributing these good comments, local knowledge comments about people or events are located in certain areas, and those who are contributing about something else, they are located in different areas. So basically, this technique and visualization can be used for managing online communities. I'll see with the time. Do we have time? 45. Do? Okay. I think I'll do. So I'll show you two other examples, which are not mine, but they might give you some ideas of what else can be done with visualizations and with analysis. This is a wind map. And why I like this map, because this is one of the tools sets now that is available for analysis of big data. Because all other map APIs, they can process 50, 60,000 records, but there is a problem visualizing larger data sets. But this one is promising. It has been built particularly for millions of records. And the idea is that on the one hand we can visualize wind and we can visualize physical processes like this, but we can also visualize communication and we can visualize socioeconomic processes this way. And another example that I want to give you, it's an example of what can be done, what else can be done with communication analysis. These are snapshots of different cities in the world: Tokyo, Jakarta, Bangkok, Moscow, London, and Paris, and their rhythms. How they talk, and how fast they reply to each other on Twitter. So basically, it's a rhythm which can be used for building business strategies, where to open the business and when to close the business, what are the operating hours. But we need more and more metrics like this in order to translate communication technologies into some meaningful data insights. So the challenges are we need to process data faster if we want to use visual analytics approaches, because some statistical techniques are slow, or we need to pre-process the data for visual analytics. Then we need more platforms like .gl, Uber platform, the one that I showed you for wind data, in order to be able to visualize massive data sets. And we need new metrics for analysis of the dynamic patterns and the communication patterns. Any questions?
I'm just going to need to pass the microphone around to any of you that have questions. So, do we have any online questions? Anyone online? No? Joseph.
Thanks so much, Olha. A very basic question. When you're trying to begin a geospatial or cartographical visualization of something, what are some approaches that you've seen to determining which visualization or collection of visualizations might work? How do you choose which visualizations to start with?
You know, sometimes it takes years to understand, and I learned this from my own experience. You see, I was taught by a computer scientist, and I was told to focus more on interactive techniques, on the role of of interactions in visualization, in understanding the data. I did see the value. I like interactive visualizations, but after that, I had to rediscover for myself geospatial techniques, which were discovered in cartography. And the difference is that cartographers are trying to put everything on the map so that you don't even have to interact. You can see on one image everything. And this is cool, but this can't be combined with interactive techniques. Once it's combined, then you can see how their patterns are changing over time. Because nothing is static, everything is dynamic. But it took years in order to understand this.
Thanks, Olha. Thank you.
Thank you.
Oh, yeah? Oh, do we? Oh, sorry. Sorry, I missed you at the back there. I'll just. Okay. Maybe if you just tell me the question, I'll repeat it for the online viewers.
Sure. So basically the question is that one of the challenges that I have seen myself is that showing lots of data, visualizing lots of data is not very useful for the end user, especially the business people. They want to see less. They want to see that what are the top 3, top 5 things that I need to focus on today instead of just showing everything on maps or everything on the data. What are the best techniques that you suggest here to find those top things and show it to the business people?
So I'll just repeat that. So what are the techniques that you can use to, I guess, can I say, to show the most relevant things for the end user instead of showing everything in one place?
Well, you can definitely highlight and maybe show it with a different color the techniques, but there is another problem that I see here. And the problem is that many of these techniques are new. They existed in static visualization tools, on desktop tools, and people are not familiar with them. With many of these techniques, you have to explain to people that this is useful and this can be used. And we're basically coming up with the scenarios how this can be used. How many business people are taught that, yes, you have to look at the top things, you have to look at, but, in order to optimize the business, you might not always have to look at the top, or at the three top. You might find some other ways. And visualization is about visualizing a larger space. Showing everything, how all these parts work and how they interact, and about emerging patterns. That's what is not very easy to explain to many business people. But there is a value in explaining all these groupings, all these clusters that emerge in visualizations, because there could be a different behavior hidden behind these clusters and behind these communities. And that's what they have to pay attention to, because looking at the top performers, I don't know. That's my point of view.
Great presentation. So when you deal with large sets of data, how do you deal with erroneous data? How do you reduce the effects of erroneous data on the error of a visualization? What are some of the methods, I guess?
There are many papers, and there was even a dissertation on Iranian's data and how to represent Iranian's data in geospatial data sets. If you're interested, like, I'll try to recall the name and I can give you, but this is certainly a very big issue. You know, when publishing in business journals, like many researchers don't want to even hear about mistakes with coordinates, with everything, but what visualization community is pushing for, that we have to show this all the time. And we have to show like errors in geospatial analysis, errors, because when people finally see what is going on, they might think differently. But also there is also a need to explain to people how to report this dynamic how to report the dynamic findings, and how to report erroneous data, and like what's allowed, what is not allowed. For example, in this Japanese data set, I was told that we are allowed to have like 2 or 5% error. But it's international business, of course you cannot find all locations in China, especially when they were translated to English. And when you use automatic geocoding, I used semi-automatic. What it means that I was still looking and whether I'm accepting the geocodes offered by Google Maps, Google geocode, or I'm not accepting. And I thought I did a perfect job. But later when I checked how many coordinates were accurate, I was shocked. Half of them were had the same coordinates, and later I realized why it was, because sometimes it gives you, especially in Shanghai, in some new areas that were growing, and they didn't know the location, so they were giving approximate locations. I thought it was probably okay to take that approximate location, but I wish I knew before that half of them were. Had the same locations. Maybe they are close, maybe they are not, and you never know. It's international business. But this should be done, this should be addressed. But the problem is that the faculty are pressed to publish, and it has to be published. And no one wants to say that I'm doing something. That is questionable, but it has to be done through the visualization at least.